worth it.
I definitely agree with Tabby. I did this competition 2 years ago and it was my favorite part of the semester. So no matter my schedule or what was going on, I had to do it.
For me, like the other two, the pandemic made, like, spending the second half of the 2019-2020 school year at home, not really getting to do anything, that made me remember how much I valued the hands-on experience and the getting to just sit down and work on a self-guided project. So to me, once I heard about the competition and what it was going to be this year, I was on board.
Fantastic. Adding on to that, you weren't the only folks who expressed interest in participating in the competition from Purdue this year. There were a line of people in my office saying, "Hey, we want to do this. How do we decide who gets to do it and who doesn't?" And I'll say that my answer was, I'm not going to decide who gets to do it and who doesn't. Y'all are going to have to figure that out. But that at most we can do 2 teams from Purdue, and that's it. So that raises some questions. How did the 3 of you, and we should mention that there's a 4th member of your team, Kelsey Chisholm, who couldn't be here today. How did the 3 of you and Kelsey determine that you would congeal into a team? How did you determine that? Were there special skills or talents or attributes that you shopped for that you decided were important? Were there things that you were hoping not to have on your team that you thought were important not to bring in? How did you come to forming your team?
So in all honesty, we took everyone's name and put them in a random generator, and that's how the teams formed. We did put some thinking in it. There were 10 people interested in general, so that means 2 people couldn't be in it. And we just did whoever has more years left, don't join, because you can do it next year and the year after. And then that left a total of 2 grad students, 4 juniors, 1 senior, and 1 sophomore. So we decided each team would have 1 grad student, 2 of the juniors, and then senior, sophomore, and use a random generator that would produce that. And here we are.
Gotcha. So I think it's fascinating that you all created a random name generator script to figure out who would be on your teams. That's a particularly engineering approach to solving this particular problem. So given that you didn't set out to create a team with specific skills or talents or abilities, do you feel what do you feel were your greatest strengths then? And do you feel like that served you well? Do you feel like you got lucky? How did that play out for you?
I think we lucked out. The 4 of us I'll backtrack. When we found out our team, we created a list of our strengths and weaknesses. And it turns out we are extremely well balanced between the 4 of us. So we were able to have a wide range of experience, but a lot of experiences that overlapped as well. So I feel like we got lucky with who we had on the team. But that's, I guess, my opinion.
Shep or Izzy, do you have thoughts about that?
Yeah, to add on to that, I think on a meta level, our team's greatest strength was the way not only we balanced each other's skills, but how we balanced each other's like work and sort of process flow. Making a list of our skills is an example of that. And then we carried that through, and we would always keep each other in check. One part that really stuck out to me was how we held each other accountable, but we were also always understanding. Like you said, Rich, it was, a packed semester. And there were weeks when, one of us had to do something and we just couldn't. And that was always okay. But, as long as we were holding ourselves accountable. So for the process, that was what I thought gave us the greatest strength.
Great. Anything to add to that, Izzy?
I think they both said it perfectly.
Okay. So a follow-up, and I wish that some of the members of the other Purdue team were here to talk about this as well, because I think it is fair to say that they ran into some struggles the day of the event. Their machine had some issues, and I will say I was impressed with how they handled that and managed that. Right, there was a lot of stress, but there was no stressful outbursts. But I wonder, do you feel like you were lucky in your team makeup and they were as lucky in terms of the skill sets that were brought to the table? And I guess what I'm really driving at is, if you had to do it all over again amongst the 8 of you, would you use a random generator to form the teams, or would there have been benefits in picking a different method?
I think further into when the teams were formed and we started, we've realized I think all of us have our own skills, and I think everyone can bring everything to the table. I don't think that we're more lucky with the people that we have. I would be more than happy to be on that team also. But thinking in experience wise of being in certain classes before, because a lot of them were just new to the program or haven't taken a class with you. I think when it comes to like writing our proposal, we have that design specifications that we always have to do. Like I personally have had you in class 8 times, so I've had 8 semesters of practice. It's okay. It's been fine. I guess I learned. No, I learned, which is why I think our proposal was really strong too, because we all have been in your class for multiple semesters and have had that practice. While some of them, they had great proposal too, but they haven't had you in class as many times have that practice. Not saying anything against their skill, because
no, but less experience. That's not a dig. That's a fact that they had less experience.
Yeah, just in, I guess, less experience in certain, just being in the class, so we noticed that as we were going through, and we were like, that maybe next time a random generator shouldn't be the way out.
So that was a thing you noticed. Tabby, you were going to say something.
Yeah. Izzy and Shep have also been in the competition before. And honestly, I think that did give us a leg up, because nobody else on the other Purdue team, I don't think, has ever done the full SNDC. So Shep and Izzy knew what to expect. We knew how to prepare a little bit better. But again, I don't think it comes down to skill level. It's just Izzy has had class with you, and it's just a little bit more experience with that.
Sure. I wonder, for us, as we think about the competition in future years, perhaps it's worthwhile sitting with you all and maybe some of the other participants from this year from other universities, and sort of talk through what things do you need to know that aren't obvious from the competition documents? Like what is helpful to know walking into it? Because as you say, if you feel like having participated once gives you a leg up, that's great, but we also want to try to make sure everybody has that information. So if y'all are willing, I'd love to have that conversation in the next couple of weeks. Awesome. Izzy, you mentioned the proposal document, and I want to circle back to that in a little bit, but I know that one of the things we want to talk about that you all mentioned you wanted to talk about was the fact that we mentioned the other team had some issues the day of the event. You also all ran into a bit of a snafu the day before the event. And I should say, in the interest of trying to be as fair as possible, I distance myself from the work that the Purdue teams do. I didn't actually see either of the machines that the 2 Purdue teams put together until I walked through the shop the night before or the afternoon before and got to see them frantically working, but that was the first I'd really seen anything. I don't participate in the judging, but I just feel like it would be unseemly for me to take a deep involvement in the work that the 2 Purdue teams do. So, but I remember distinctly Friday, right around 4:45 in the afternoon, a couple of you showing up in my office going, "Do you have a 24-volt DC motor that we could borrow?" And I don't. Can we steal the 12-volt motor that we know is in the trap room? Sure. So clearly something happened. Do y'all want to talk a little bit about that? And really, how did you work through that? And still try to present the best version of your prototype that you could?
Yeah, I'll start with that. Before I explain what went wrong, I want to share a video of the machine when it was working to give an idea of how it worked and what kind of failure we experienced.
Sure.
Is that video showing up?
Yes.
Amazing. So this is our machine working as intended 2 days before the competition. So the machine we built is a scissor lift operated by, like Rich said, a 24-volt DC motor that pulls the back of the scissor lift forward. And along that path, the scissor lift hits 2 limit switches, one of which tells it when to stop at the end. And basically, the night before the competition, we were doing our final tests of our scissor lift, getting it tuned to where it needed to be. And the arm missed that last limit switch. The limit switch had fallen in its enclosure. So the motor didn't know when to stop. And the motor just kept pulling against, a hard stop and burned itself out. We didn't notice for about 3 seconds, and that was all the time it took. This was at around 3 o'clock the day before the competition. And I actually had to leave like right away to go to my last final of the year. So, our team coordinated, like, we need to figure out how to get our machine to the point, not necessarily to where it's working perfectly, though that would be ideal, but to the point where we can show everything we designed. So I took my final while the other team members were getting organized in the shop. We came back, we discussed, and then, like Rich said, to fix the control system, we found a 12-volt motor in the shop, or in the trap room, but our system was running on 24-volt power, so we had to find a 12-volt power supply, a new motor controller, and rewire the entire system to run on a different voltage. The thing with that was the motor we found was using a much higher gear ratio, so it had a lot more torque, but it ran very slowly. So we tried to design and 3D print a gear reducer in like 12 hours. Surprisingly, that didn't work quite as well as we would have liked. So yeah, the morning of the competition, we had to figure out a way to demonstrate the effect manually. And Izzy, if you want to talk about that.
Sure. Yeah, as Shep was running around 3D printing stuff and trying to, because he took the lead of the motorized and the control system part of our machine, while he was trying to redo that, we were like, we got to figure out a plan B, because if this doesn't work, we were hoping that it would work, but if his new thing didn't work, we would have nothing to show. So we tied up how it would have been in the tiny winch that we made and just pulled it with a piece of tie line, and it did the job right when we practiced that a couple of times. But I think because we were really hoping and pushing the motorized up until, I don't know, the competition started at 8 up until like 7:30 in the morning, trying to make it work. And there was that point where we had to prioritize and find when to say, you know what, we need to stop trying to make this work and stop and go to plan B. And I think that was a pretty good way to handle that. And I think, yeah.
Tabby, anything to add to that?
I think they covered it, but also while all this was happening, we were also trying to finish up our design documents. So if it basically became like, if you weren't working on finding a solution, or you've worked as far as you can and you were waiting on the 3D printer, you were working on the design document, So it was full teamwork to get where we were. And our conversation about plan B happened the night before of like, shoot, this, like, what can we do to fix it? This is our plan to get it to kind of work motorized. But if we can't make that work, what's our plan B to just get it to work at some point? So we had all those conversations, and then at 7:30 we made the call of like, okay, we can't get it to work how we need it to, so let's just do it manually.
And
I think that's one of the. Go ahead, Izzy.
Oh, I was gonna say the day of the competition, we still had the new motor that we all found, and what Shep's new program that he wrote, we all had that. So the day of, even though we did it manually, we still were able to show the judges that, hey, if this was hooked up, if the motor was hooked up, this is how it would work. So we still got to showcase the control system and the motor and what we did, which I think helped a lot too, because it kind of showed the whole mission. But also to add to Tabby's, what she said, where it was, if you're not working on plan B, you were working on the design document. We also had like Kelsey ran to Walmart and was trying to find like, I don't know, like a remote control car or a drill battery, any type of motor. Tabby was calling all of these shops that might have tiny motors, and even talked to, was it your brother or your dad, who lives like 2 hours away, right? And to see if because there was a motor in their garage, to see if they'd meet us halfway. So it wasn't like either this or this, like we were all doing our own thing.
So
trying to make it work.
That to me is one of the most interesting things to talk about is you mentioned that there's a moment where you have to make the call and decide whether plan A or plan B or C or D or E or whichever of, dad coming from 2 hours away, whichever one it's going to be. And I know that that's not something we explicitly talk about in any of my classes. And so I'm wondering how did you all decide when the moment was? Like, what are the steps that make you say, we're going to keep going until this moment, and then at this moment we have to decide something, and then how do you make that decision?
Izzy, do you have something?
You can go first if you want.
Yeah. All I was going to say is, I think it started with a conversation of looking at the situation realistically and saying, if we try this plan, how long is it going to actually take us to do it? And is that enough time to troubleshoot it? And then just kind of taking steps from there. So it's really just looking at it in a realistic manner, I guess, and just being really honest with everybody about whether or not we can do what we need to do. And then we also talked about what our priorities were. Like, if this doesn't work, what do we need to have at competition? And then discussing it further among the team members and prioritizing that way. And we ended up going manually, but yeah.
So to piggyback off of that too, my teammates know, like, I personally was on, okay, this burnt out, like when it happened, I'm like, we're doing it manually. Like, I was like, we can try it, go ahead. But for me, it just seemed like, as brilliant as Shep is, like, we all know things go wrong. And so I personally looked at it more of kind of like what Tabby said, prioritizing, okay, what are the specifications? What do we need to deliver on competition day? There's going up in 18 inches in 2 seconds, going down in 10 seconds. It has to be a single trigger method. So nowhere did it have to be mechanical or machine. It could have been manual, which a lot of teams did, like a mechanical approach. And it had to fire the dart. So of the things I was willing to give up, and when making decisions too, we ranked everything of how important it was to hit it, even though that single trigger was really important and high on the list. There were all these other things that were almost equally as important. But if we did it manually, we'd be able to hit all of those, like going up in 2 seconds, coming down. The only thing we lost was the single trigger. That's the only thing we lose by switching. So for me, and the reason why I was so quick to be like, okay, let's do it, is because even if we did get it to work, we, like Shep said, the gear reducer was much larger, so it'd go a lot slower. And that's one thing we'd lose, speed. It might have not even worked, so we might not even be able to get our 10 shooting, which is another thing we lose. So I kind of weighed of, do I want number one, or am I okay with getting 2, 3, 4, 5, 6? So that's how I personally was like, okay, let's do this. Let's just figure out the hand.
But that's, I mean, that's a really tricky thing to do, right? Is to prioritize, because this happens often on senior capstones. Shep and Izzy, you have your senior capstones coming up. So this is a good learning moment, right? Or thing to remember. That you have to make a choice between continuing to struggle with what your design was and do what works for the design, or do what works for the production in the case of a capstone design. And that's can be a heartbreaking choice to make. And so Shep, I know you were going to say something, and I wanted to ask you this and sort of maybe tee you up to talk about this, because it's clear that you were really sort of pivotal and central to this idea of it being motorized with an automated control system. And so I have to imagine that decision-making moment might have been challenging for you, right? Like, there's a moment where you have to give up what you've been fighting for. Do you want to talk about that?
Absolutely. And to me, I think it speaks to what we were talking about earlier, the way the team members hold each other and keep each other in check. Because what Izzy was talking about, her prioritization of getting B, C, D, and E, but not A necessarily. I was, obviously, since I was the lead designer on the control system, I had been focused so clearly on that part of the competition that it had wormed its way into my brain as the most important thing, in my opinion. And before the competition, I was convinced that the single trigger was really the crux of what we were trying to do. And without a single trigger mechanism, our machine wouldn't really be fulfilling the criteria of the competition. And I think it was a really important moment when Izzy was talking to me, the morning of the competition about the reasoning she just gave. In me realizing, okay, there's more to this than just, the thing that's been the top priority in my mind since.
Sure. And that's the trick, right? Is being able to prioritize the entire project, not just one part of it, or the thing that you've been focused on. And that's hard, right? So kudos to y'all for finding a way through that. Related to that, I guess, maybe that's just a poor segue, a ham-handed segue. But I recall at the competition, so I've got my little computer set up, I'm on, my camera, and you all and the other team are behind me on stage, either setting up your devices or showing off your devices, or watching on your laptops, the other teams. And I distinctly recall many, many moments of gasps or oohs or ahs from the 8 of you behind me as you watched other teams doing stuff. And that's one of the things that drives or one of the goals, I guess, of the machine design competition is the opportunity to learn from each other across schools and universities and practices, right? Because the way they do things at Kent State is different than how we do things at Purdue. And so their design process and their prototypes are going to be different. And that's an opportunity for you to cross-pollinate and learn. So what are some of the observations you made that day that made you go, ooh, or ah, or I wish we'd thought about that, or I would have never done that? Can you share some of those things?
We talked about this before, and the number one thing on all of our lists was Valparaiso's counterweight system, and they used sand. And we were all, I remember that was the thing that even you were like, everyone was like, oh, because what a great way to have a counterweight that changes weight.
So for the folks who are watching who weren't at the competition, which is probably anybody who isn't the three of you, the Valparaiso team utilized a sand container to lift the dart launcher up, but it also had a drain plug in it, and they calibrated the amount of sand so that it would create the timing required for the head to go up, or the launcher to go up in 2 seconds and drop down in 10 seconds, which is just sort of mind-boggling, right? They created a sand timer counterweight combination system. So everybody, I lost my mind at that. The judges lost their minds at that. And absolutely the folks on stage at Purdue lost their minds at that. So yeah, amazing. Other things that y'all noticed?
Well, I mean, even like the other Purdue team where their device was mechanical fully, like it had no motorization, anything like that. And that was something like what Shep was talking about, where we had an idea of like motorizing it, and that became what was a priority for us. So we never even like considered that type of option, or even like the sand option didn't even cross our minds. But with Purdue, the other team, I feel like their device fit the theme really well. Like Izzy and I were talking, and if we walked into an escape room and their device went off, that would scare the living daylights out of me. So it was just so fitting for that type of theme that I thought, that was a brilliant idea on their part.
Can you describe what about the design was like? How did it work, and how did that make it fitting?
Yeah, so basically if I remember correctly, it's been a couple months, they essentially pulled a string and the entire head popped up on springs and shot the dart. I don't know if there's actually lowered or not, but it's just so abrupt that it kind of fit the theme, in my opinion.
So a takeaway from that for me would be to talk about acceleration envelopes as well as velocity envelopes, right? Like watching your video, it's a fairly what we might call a smooth motion, right? Like it accelerates half the move and decelerates the other half of the move. But it sounded like their attack, the acceleration was really high, and then it slammed to a stop, right? Interesting. Shep, what struck out for you?
Look, honestly, not to beat the drum too hard, but I haven't been able to stop thinking about Valparaiso's sand contraption since the competition day. Like that to me is why I love these engineering projects for theater specifically, is that, in everything I see like simple concepts used in wildly intelligent and creative ways, and that's a glowing example of that, in my opinion.
I would agree, and just as a shout out to our colleagues at Valparaiso University, it was an all undergraduate team, right? There are no graduate students at Valpo, and it is a particularly small theater program, right? I think they may be the only 3 theater technology students there. I don't really know that that's true, but I know it's a relatively small theater program. And so for them to deliver that kind of a project is really exciting. And we should also mention that in addition to Kent State that we talked about, there was an all grad team. There was a team from Michigan State. There was an all undergraduate team. And one of the things that struck me about their project, well, I guess one of the things I'll say about the Kent State project is that they went to the trouble of building sort of a room around their design, which was really exciting, right? So there was sort of this themed box around their launcher, which was very, very cool. And then perhaps the 3 of you don't know this, but the Michigan State students, they were all remote for most of the year. So all of their design process, everything happened through Zoom like this until the last few weeks. Which was also really fascinating and says a lot about their work. Okay, Anything else that you want to say that sort of stuck out for you, or that you were like, oh my gosh, I wish I want to think about that for the future from the other teams? It's okay if there isn't, that's fine.
I thought the design of the Michigan State device was, or the device looked very clean and very polished, and I appreciated that a lot.
They were also the ones that their dart firing was extremely accurate. Was it like a crossbow method?
It was a pneumatic. It was a pneumatic cylinder that lifted and a pneumatic puff that pushed it out.
Okay.
But yes, I am a target archer sometimes, and they had what we would call a tight grouping. All of those darts landed just about at exactly the same place, which was kind of amazing. Absolutely. So we have a few minutes left. I want to open it up to some questions from the folks who are attending, but we talked before about wanting to circle back to your proposal document. And that was one area in which the judges spoke quite a bit about how they felt you had excelled. And it's probably also something that took you a lot of time to create. And for those who are watching, attendees needed to submit a proposal, a design proposal in January or February, I forget which. And then had to create design documents that documented the actual creation of the prototype on the day of the event. So there were 2 sets of documents to create. Can you talk about why you thought your proposal was so strong, and how you went about preparing it?
So from what we talked about a little bit before about being able to be in your classes, is what we have to do before every project is create very similar, our design specifications, our concept ideas. So we kind of already knew, since all of us have been in your class at least once, kind of where we should start with it. And that gave and kind of just the best ways to convey that information with our design specifications and where to start in the design process of understanding what we need to do. Another thing is that Shep and I were both in the competition 2 years ago. So we've had that practice, and we know what the other teams' proposals look like, what our proposals look like before, and kind of the idea that we needed to go for. Along with that, though we saw what we needed to provide, we also provided what we thought was important. So we had some parts in it that wasn't in what needed to be done. Like for our design document, we had future improvements and just ways that we wanted to make our design better and how we would achieve that in a section like that. We also understood that with this proposal, we needed to document a lot of stuff. And while writing it, it's that idea of not over communicating stuff, that every word has to matter so that it's concise, informative, and not too long for someone to read and then lose their train of thought. So that's kind of the ways that we attacked that. And it definitely took a long time.
Sure. Shep or Tabby, anything to add to that?
To jump on what Izzy just said, it took a long time. I think one of our, something smart we did was we started talking about the competition as a team during winter break. So we took our time getting familiar with the design specification and all the criteria. So we had already built the foundation of what we wanted to accomplish when we got back to school in January. And I think that helped a lot, not having to rush that process and being able to really take our time.
I don't think I have anything to add, other than it did take a lot of time. But yeah, we just tried to include everything that we thought would be important, that mattered. So yeah, I think Izzy and Shep covered it.
So let's be honest, creating a proposal document is not the fun part about a competition like this, right? The fun part is getting your hands in the building process, the testing process, like making the thing. And the moment of exhilaration when you finish the design proposal document is not at all the same as the moment of exhilaration when you push go on your motor and it moves and it does the thing, right? Like, let's be realistic about that. And so that calls it a question, right? Like, why should I spend the time doing the proposal document? Because it's not fun. It's not the enjoyable part. It's not the part that I most want to do. And maybe I'm wrong. Maybe that's just me, but I'm guessing by the facial expressions you're making that you all feel similarly. Do you think there was an advantage to creating that document before you did any of the actual design prototyping work? And what were the advantages? How did it help you?
Definitely. So when we, at the end of our proposal, we had to say, hey, this is what we're going to design. And that's definitely not real. Actually, it was pretty close. It's actually kind of funny how we circled, and we mentioned this in our proposal. We ended with, this is what we're going to do. And as the months went on and we saw that it didn't work, it was really nice to be like, okay, we need to try a new concept. Let's go to this one. This one ranked really well. We really liked the pros and cons. So it was really nice to have all of these plan B, plan C's of concepts that we could go back to, and we didn't have to sit there and try to brainstorm something new. So
that's
that
an
was
interesting
definitely
point.
helpful.
Can I just clarify that what you built and presented was not what you indicated you were going to create in your proposal? And that's not a judgment, it's just a statement, right? Like, you don't have to feel bad about that, but.
No, I wasn't. So it's actually kind of funny because we talked about this pretty recently. And we even wrote about it. What we had by our end of the proposal was actually pretty close to what we ended up with. But the process getting there was, at the beginning, we're like, actually, no, we don't want to do this. So we went very far away from only to end back up to where we were. Gotcha. And that was something that something like a future improvement or successes and failures in our team is that, we got to trust ourselves more. Obviously, I mean, not obviously, but it was different. It wasn't like
sure
same exact thing, but we still stuck with the scissor lift idea. We still stuck with a trigger being pulled by a string when it gets up there. The key concepts were the same, which was pretty interesting considering most stuff that I've personally have ever designed or something, it's usually way off of the original plan when you start getting your hands into it and doing the detailed designs.
Gotcha. How else did the proposal benefit you, like having done that work, benefit you in the actual prototyping, experimenting, and build phase? Tabby or Shep, anything?
I mean, I kind of what Izzy said is, I don't know if this is necessarily a benefit, but when it came down to the very end, we did go back to some of our original concepts. And I feel like if we had looked at our paperwork during the process, we would have realized that our original designs were strong enough on their own. But as challenges occurred, we just strayed away from all of our designs, and we were trying to design our way out of it with different ideas. And if we would have looked back at those and trusted our documentation, because we had it all ready, we never looked at it during the process. So if we would have looked at it, it would have been extremely helpful, and we would have gotten to our final design faster.
Gotcha.
To add something real quick, another thing that I think it was very helpful was at that point where we had to make that call from switching from using the motor to working it manually. It was nice to be able to go back to, okay, what are the A, B, C things that we need to hit? How did we rank it the priority back then when we were talking to our client, when we were talking to the understanding the specific aspects of it? It was nice to be able to go back to that and understand what we were thinking at the beginning and carry that through until the end.
Sure. Makes sense. Well, I want to open this up to the folks who are attending today, see if they have any questions. If you all have some questions, you can start typing them up in the chat. And as you're doing that, I'll just ask the three of you, is there anything else that you want to say about your experience, the competition, anything you want to add that we haven't really talked about?
Had a good time. 10 out of
It's worth
10.
it?
Yeah, it was fun. I think if anyone's really interested in doing this in the future, like, go for it. It was great to get that hands-on experience. And even the parts where I was about to break down and cry when our motor stopped working, and had to go stop and go eat dinner and cry into a Chipotle bowl. Still would recommend that. Still was great.
I definitely think participating in the competition, I think I was talking to Izzy and Kelsey about this. There's so much ingenuity and resilience in our generation of grad students and undergrad, that it gives me a lot of hope for in the future of our industry, especially because we've taken a hit with COVID. I think we have a lot of great people, and that's exciting to me.
Absolutely.
In my opinion, doing the design competition, in my experience, has been the closest I've felt to, like, not to toot my own horn, but being a professional. Not to say I'm a professional, but when I think of what my professional life will be like, I hope it will be like, getting down with a team of people and working together to solve a problem. And, I think, I hope that the design competition experience is how that's going to be in the future, for me.
Sure. Absolutely. I'm not seeing many questions in the chat, so I'll just keep asking questions. By many, I say I'm not seeing any questions in the chat, so I'll just keep asking them. And if y'all have some, throw them up there. We have in the past had students from other institutions express interest in participating in the competition and then sort of back away from it. And so a question that Dr. Pillatt and I both have for all of you is, what is a piece of advice you might give for a student, or students who might be interested, but then find themselves maybe intimidated or a little anxious or leery about entering a competition like this? What would you tell them?
Start early.
Okay.
Yeah, and push through and just do it, because it's well worth the stress.
I would both give this advice to freshman year me and whoever is having this dilemma. It's called a competition, and there are prizes at the end, but really the spirit of it is a showcase of ingenuity and work. And there's something in every, you spend X amount of time on a machine, and there's going to be at least something that 90% of people in that room think is very cool. And that's my favorite part about the SMDC. And that's what I would encourage people to strive for, making something cool that will get eyes and get people thinking, rather than, I need that grand prize.
Sure.
Definitely. I think, along with that, I think if it's the time commitment that's scary, I mean, your thing doesn't have to work. Like, obviously you want it to, but if that's what you're scared about, of like, oh, I can't think of something that's going to hit all of the like everything that they need, or it needs, or I'm so scared that it's not even going to do anything or something like that. Like, ours didn't hit everything that it needed to hit. There's been multiple in both competitions, multiple teams where it's like they show up and it just decided to just not do its thing, which it's totally okay with, because it's really the coming together, like Jeff said, having those ahas and seeing what everyone else had to show, even whether you hit every single part of it or not. It's all about just the ideas. I still think about 2 years ago when I was at the competition, I think it was Illinois, their retractable loading device, which probably means nothing to the people who don't know what I'm talking about, but it was a really cool device. And it was one of those things that went like, oh, and I'm still trying to figure out how I can put that into my next design of something, is because that was just one of the most brilliant things. And I still think about it.
Sure, sure. So one of the things that's interesting to me to ask about, I'm going to get selfish now. We've asked questions that are sort of broader strokes for all sorts of people, but the 2019 competition was in person. The 2021 competition was canceled. The 2021 competition was mostly virtual. And one of the things that really struck me in 2019 was the sense of camaraderie that came out when things didn't go well, right? When teams had some struggles with their machines. And there was a real sense of the entire room rooting for whomever it was to try to get their machine working or to solve the problem. And then when it did happen, cheers come up from the whole group. And we experienced similar challenges for some of the teams in the virtual 2021 experience. Did you feel the same sense of camaraderie and support? Was it able to come through the Zoom environment? And part of the reason why I ask is, though Indiana is central to the US, sort of, it's a long trip for a one-day event to show off a prototype if you're not from a couple of hours away. And we definitely want this competition to be accessible for folks from, across the country. And so we're actively considering a hybrid version where there's an in-person event that's added to by having folks participate virtually in the way that we did this year. Do you get the same experience? And I guess Shep and Izzy, you're the only ones who've done both. So did it feel the same?
I want to say with anything that went from in-person to hybrid, there was a huge difference. Sure. I don't think that this competition was special in any way that like it didn't feel the same, like everything.
Right.
I do think though that of the different things that went virtual, this worked a little bit better than the average thing. That camaraderie, oh man, of being in person and hearing those oohs and ahs was something that was definitely like feeling missing. Luckily we had two teams, so it was a little bit more. But I think since most people kept their camera on the whole time, you could be like, oh, wow, and see it on their face, which added a little bit of it, which is nice. I think a hybrid would be great for the people. I mean, more to see, but you also lost a lot of the talking during the breaks with other other teams and meeting them and talking with them. So yeah, I sorry about that. Yeah.
Okay. Shep, you were going to say something, I think.
Yeah. One of my favorite parts about the competition back in 2019, like as Izzy said, was talking to people at lunch and, like going really deep with them on like one aspect of their machine that stood out to me. And that's, I think, the main thing that was lost for me in this year. But, also, I think a hybrid format would have a lot of benefits in that it makes the competition more accessible to people on the East Coast or the West Coast. Personally, I would make the trek to Indiana to get the in-person experience because I loved it so much back in 2019. But I would also, I would absolutely love to see what people would come up with if the competition was exposed to more of the country and more colleges.
Sure. That's really helpful, and it gives me some food for thought as we begin thinking about the 2022 event and what we might do to try to capture as much of the feeling of the in-person event in a hybrid kind of environment. All right, we are just about at time. Beth says thanks to us for making this competition happen, and I feel obliged because she's here. Beth Martell is watching. This is an evolution of an event that Beth started at University of Illinois Urbana-Champaign many years ago, the Midwest Machine Design Competition. Where we are now owes much to her vision of that event. That happened for a long time before she moved on from there. So we're thrilled to have you here, Beth, and thanks for your support. Anything else the three of you want to add before I let y'all go? Awesome. Well, thank you, the three of you. Thanks everybody for participating. It's been great having y'all here, and enjoy the last few weeks of whatever summer is left for those of you who have a summer, and we'll see you hopefully next month. Thanks, everybody.